because now if we play, we can move the player around, we can rotate it, we can make it bigger, and we can save the transform. And now during gameplay, we can use load transform, so bring it back there. You can also close and start again, and even in between playthroughs, the data is still saved. Hi, I'm Ricky. Today we see part 2 of our custom save manager. We've seen how to save and load serializable data in our game before. Today we see how to delete data and how to handle unserializable data. If you haven't watched part 1 already, go watch it now. And remember, you can always download the entire project for free from Github. Alright, so let's start. As you can see, I've made some modifications to the menu. I've added 2 buttons for delete all data and 1 for delete file. We still haven't implemented the save and load position buttons, but first I want to start with deleting data. So let's open the save manager and let's make a new function. In here we need to check whether the saves folder exists, so we can just copy this bit of code here. And if it does exist, we delete it. As a parameter we pass in the saves folder path, and we also set recursive to true. By setting recursive to true, we tell it to also delete all the files that are found within the saves folder. Now this already works, but to actually call it with a button, we will need a reference to the script. So I know we made the script static, but instead let's make it again monobehavior. This won't change how this script works, because we have made all the functions static. The cool thing is though, that now we can go back to Unity, and we can create a new save manager game object, and we can now add the save manager because it now inherits from monobehavior. And now if you select or delete all data button, we can add as a function the save manager's delete all data. If we hit play, you can see that right now I have a saves folder, and if I open it I also have another file inside, but if I delete all data, the folder is no more. Okay, and now to make it even better, we can add a menu item to delete all data, so that we don't have to play the game to delete the folder in our computer. To do so, let's go back to Save Manager and let's import the Unity Editor library. It's really important that whenever we use the Unity Editor library, that we do not build the game with this library within it. Basically, we can only use this library within the Unity Editor. If we try and use this library when the game is already built, we're gonna get some errors. To do this, we use conditional directives. This is basically like doing an if statement within the code itself and not during execution. So if you are not in the Unity editor, this isn't gonna be built. Let's copy this bit of code, and now let's go down. And above our delete all data function, let's add an attribute called menu item. Menu item uses the Unity editor library, so let's also encapsulate this menu item attribute within the conditional directives that we used before. And that's it. Let's go back to Unity. A new menu will have appeared here in the top left, and you can press it to call the function. Using this new menu that we made here, or calling the button during gameplay, we'll do the same exact thing. This is really useful when we are still making the save structure of our game, and we may make some errors, create some files that we really didn't need to make, stuff like that. Alright, next up, let's see how to delete one single file. Let's duplicate delete all data. And in this case I called it delete one file, and we're also going to require a parameter for the file name. And now we just need to concatenate this file name with the saves folder. And I've renamed it to file path, and now instead of directory.exists we use file.exists. And we don't need to pass it the recursive variable. Now we just need to pass in the function. And if we want to call this function from a button, we just need to pass the parameter here. So for example, let's play again. Right now I don't even have a saves folder, but if I say save stats, now I have the saves folder and I have a file called player_stats file path. I can copy this file name. And if now I put it in here where I say delete one file, delete file, and now that file doesn't exist anymore, but we still do have the saves folder. Alright, so that's about it for deleting data. One last thing that we can do is making the code a tiny bit more secure. You can see that we're using path.combine to get the saves folder path many times within our script. So instead, let's copy this function, and let's make a string property that returns this function. This way, we don't need to use the path.combine function every time. We can just use the property. And we also don't risk pasting wrong the saves file. In this case, we don't even need to make a new string anymore. We can just use the property. We can do the same for load data, delete all data. While for delete one file, because we're not getting the saves folder directly but the file path, we combine the saves folder with the file name like this. Perfect. Alright, so next up is saving and loading the player's position. We're going to do that in the player script, so let's open player data save. In here, let's make a new serializable class to handle the player's transform. We can't save and load the transform component directly into the save manager, so instead we'll have to make a fake transform ourselves. A transform is made of 3 vector trees. So in theory, we just save these 3 vector trees independently and then use them to fill in the values of our transform. The problem is that vector 3 are exactly like transform. They're not serializable. So instead of a vector 3, we're going to make our own type of data. We're going to make an array of 3 floats. For now, let's just do the position. And now when we save and load data, we just have to fill in the positions array, where the position 0 is the transform's position x, position 1 is a y, and so on. And now when we want to save or load the player's transform, we just have to fill in manually the elements of the position array. Let's start by making new values for the file path and the player transform data. And let's also duplicate the functions for saving and loading it. Of course, we don't want to make a new function for everything that we want to save in our game. Usually you just have one singular file for all your data, but in this case, just to show you independently how they work, I've made a new class and I've made 2 new functions and I've made a new file path. If you go to Unity, let's link the 2 new functions of save and load position. And now if we play, in our player, by default, the position is an array of 3 floats set to 0. Now we can change the values and save the position. Now if we can close and start again, if we load, so right now this is working exactly like the player stats. Now we just need this part of data to reflect our player's transform. So before we give our player transform data when we save it, let's first set the values to reflect our transform's position. And we do the opposite when we load it. This way we have destructured the transform class into 3 vectors and the 3 vectors in 3 floats each. If we wanted to copy the rotation and the scale as well, we just need to repeat this process. But you see that now if we play and load position, our position is going to change based on these values. Let me actually reset the player. And let's move it around a bit. Now if I save the position and close and start again, I can load it back there. I'm very quickly gonna do the same thing for rotation and scale, just to show you that it works. Alright, so that's it. You can see that rotation and scale are exactly the same. They are float with 3 elements. And loading the data is just like for the position, except for the rotation where I use quaternion.euler. And for saving the data, it's also very similar. Let's go to Unity. I've also changed the button names to save transform instead of position, because now if we play, we can move the player around, we can rotate it, we can make it bigger, and we can save the transform. And now during gameplay, we can use load transform, so bring it back there. You can also close and start again, and even in between playthroughs, the data is still saved. Alright, so that's it for this video. Hope you learned something new. Make sure to like and subscribe and share the content if you liked it. And remember to follow me on Twitter to get updates on whichever video I'm making. Right now, I'm also developing a new game. It's called AA, and it's coming for PC. I've made both a teaser trailer and a gameplay video about it. All links in the description. Alright, and I'll see you next time.